as long as it's not a complicated question. This is a review. It looks complicated, but I think you've seen this slide. Mohammed probably covered that. And basically, you have slow waves, and as long as the slow waves reach threshold, you'll have firing. Other things will lower the activity, and it's called hyperpolarization. Goes way below threshold, it's more difficult to fire. So what we're going to be dealing with, as I got it outlined here, is excitatory neurons in the enteric nervous system and inhibitory neurons. Both types of neurons are present, right? We covered that, right? And the things we're going to be dealing with, the neurotransmitters, are VIP, nitric oxide, being inhibitory. They're going to relax smooth muscle. They're going to inhibit any contraction. The excitatory ones are acetylcholine and substance P. I also have PER here. You covered that, right? Basal electrical rhythm.
No.
All it is think about basal electrical rhythm, slow wave. But the rate changes depending on where you are in the GI tract. In the stomach, you're only going to get contraction. Maximum number of contractions is 3 times a minute, 3 to 4 in humans. Okay. And that's because you only have 3 to 4 slow waves per minute. That's the only, not every slow wave will lead to contraction. In the duodenum, it's around 12. Then as you move down to the ileum, it becomes 8. Okay. We divided the stomach functionally into 2 regions, functionally, not anatomically, and we'll do the same thing with motility. Okay, there's going to be the ORAD region, that's the terminology used, and the caudad region, or proximal stomach, distal stomach. Okay, you'll know this one by heart. Okay, it's a nice little figure, tells you a lot. The functional divisions that I talked about, proximal or ORAD, distal or caudad, is dictated by the pacemaker region. I got this little line back here, which is the same thing as that line. And why are we there? Pacemaker. Oh, we haven't had cardiovascular yet. Okay. You know what a pacemaker is? It's the one that starts everything. For example, in this part of the stomach, proximal portion, you're going to have no slow waves. You're not going to have rhythmic contractions, right? There's no slow waves to dictate peristaltic type of contraction. And below this, you will. The slow wave. Again, the BER, or the number of slow waves you can have in the stomach, is 3 to 4, and that's why they usually write 3 per minute, 3 per minute. And you can have contractions in this part of the stomach, and they show you that with these indentations. That's a contraction. There is no indentation to it. They just show you slow up. We'll cover it, okay? All right, so in the proximal part, no slow wave, slow and tonic. You know what tonic means? It's steady, okay? And we'll come to that. It's highly distensible. It can accommodate a lot of material, this area. This area cannot. It's a thicker. Have you had anatomy? The muscular anatomy? You're supposed to. Anyway. The muscle layers get thicker as you go down toward the antrum, and then the pylorus is a real thickened area, and pylorus is a sphincter, right? All right. But at any rate, this area up here is thinner, and it accommodates as you're ingesting food. That's why it's called the gastric. You know what a reservoir means? Something that holds something, whether it's a water reservoir. In this case, it's a food. Well, it couldn't be water, too. In a distal stomach, you're going to have slow waves. Peristaltic contraction, low distensibility. You can't distend it very much because of the musculature. And it's primarily involved in mixing and emptying. You see there's a large food particle, small, and what leaves into the duodenum is very small particles, okay? Let's take a look at that, as I said, okay? Now we're going to focus on the proximal part. Highly distensible, gastric reservoir, right? We just covered that. So I got what I underlined here, accommodation, and something called fundic emptying. And one way to think about the stomach, I don't know if you guys cook or not, Have you ever homogenized or blended something or tried to make orange juice from an orange? The proximal part of the stomach, pretend it's your hand, pushing down on the food. This part here is the blade that chops everything up. Do you understand what I'm saying here? Very simple analogy. The upper part of the stomach is going to slowly push down the food towards where all the mixing going to go on, okay? So if you look at it that way, you can see accommodation means it's an active thing. It's going to involve neural reflexes, but the stomach wall will open up, relax, to accommodate the food, okay? Fundic emptying is when, like your hands, the stomach will start to contract down toward, pushing the material down towards you. There's no nose at the bottom. Is this okay? We're okay with it. Pretty straightforward. It's like a blender if you think about it. All right. No slow waves, so that's the kind of contractions we're dealing with. We're not dealing with, you know, okay? Have you seen this manometry, pressure tracing? Has Muhammad ever done that with esophageal peristalsis or anything? I got an appendix. I don't want to go all the way back, but basically they stick a tube down here into your esophagus, and the tube has holes in it, different places. And so if a contraction's occurring around this hole, pressure's going to go up. Is that right? Relaxation occurs, that hole's going to measure pressure going down. Let's look at this. You have swallowing here, and over here, peristaltic contraction, right? Well, this is the same thing as the LES, lower esophageal sphincter, okay? And as soon as you swallow, did you have this? The lower esophageal sphincter relaxes. Did you cover this in swallowing?
Yes.
Yeah, it relaxes even before the food reaches it, okay? So, a neural reflex. And then it overshoots, and the reason for that is it wants to close really fast before anything from the stomach goes back up into the esophagus. You covered that, right? Nothing new. What's new here is the fundus, the proximal part of the stomach. It too relaxes even before food has reached the LEF. As soon as you swallow, it's already starting to relax, okay? And that's called receptive relaxation. There's no food there. It just relaxes. It's a neural thing. We'll cover that. And this is what we're talking about here. Here's your stomach. I took it from somewhere. You have basal tone, one, and that's cholinergic. I have it in black. Acetylcholine. You're going to have basal vagal tone, right? You know that, right? And so you're going to have some tone in the stomach, right? Receptive relaxation is what we just talked about. The receptors are, when you swallow, you're going to pharynx, upper esophagus, oropharynx they call it, but you have receptors up there, and they're going to fire, vagus, okay, goes down to the enteric nervous system. These are the intrinsic inhibitory neurons in the enteric nervous system. They're going to release, based on the first slide I showed you, VIP and nitric oxide, NO. Okay? They're going to relax the fundus. And this is before even food comes into play. Accommodation now is you're accommodating something, right? And that's when food is hitting the stomach. So now the food is building up in the stomach that I'll accommodate that further relaxation, okay, based on receptors in the stomach. And we'll get to that. And then when the stomach empties, you're going to come back to basal tone. Okay. So far, so good? You know that if you're going to have to relax, you're going to have an inhibitory interneuron working for you. It's going to, more than almost always, it's going to be VIP and nitric oxide. Okay. We covered proximal stomach, right? There it goes. Now we're going to cover the distal stomach. That's the lower part of your blender. So you're moving food down, right? Now in the distal stomach, you have the pacemaker region starts here, so you can generate contraction. Up here you can't. It's just a tonic kind of contraction, right? You can generate peristaltic contraction, grinding of solids. And here you have it underlined. Yeah, you have it underlined. Filling, mixing, corpus antrum in this area here. And we'll cover that. And then you can have emptying. And of course, everything's going to happen at the basal electrical rhythm generated by these pacemakers. And some people feel it's the interstitial cells of Kajaf, ICC cells. You had that?
Yes.
They think they generate that. Okay. All right, this is manometry again. And this is pressure, so this is a contraction. It's not a slow wave, it's a contraction, okay? And what they're showing you here comes a contraction, and then 20 seconds later, that's 1/3 of a minute, another one. So you'd have 3 of these per minute, max. Is that right? 3 contractions. So this is a contraction. And the reason I do the blue line there is for 2 reasons. Okay, and let's get to this. Now, you see 1, 2, 3, 4, 5. This is where the holes are in that tube measuring these contractions. All right? Up here, you're above the pacemaker. No contraction. Of course not. No slow waves. Right? There's no slow waves in the proximal part. You can't get contraction. You'll never measure a contractile event, right? Now when you get to 2 where the slow waves are starting, and you can get contraction, and you'll have your first contraction. Now if it was going down at a steady speed, this blue line would look like this. But it's not. It's getting faster as it gets towards the pylorus, towards the antrum. So basically what's happening is you're getting this contraction goes smashes right down into pylorus. And pylorus is usually closed. So guess what happens? Everything gets pushed back. Mixed up pretty good. So, first of all, the speed gets faster. So you're slamming things right down. You're not just going, right? All right. Now the other thing is, see the height of these things? That means the strength of the contractions are increasing. So not only are you speeding up, but as you get towards the end, it's an extra harder push towards the pylorus. Is that okay? That's okay. Pretty straightforward. But if you think about it as a blender and how this thing might work, it sounds pretty logical, right? Now, the pylorus is usually closed, or they say that you can't get things out of the pylorus that are larger than, oh, there it is, 1 to 2 millimeters. You know what that looks like? You have a ruler that has millimeters on it? Take a look. It's really small, okay? Let's put it this way, smaller than a kernel of corn. Well, if anybody has a ruler, do you know what I'm talking about here? 1 millimeter?
Yeah, 2
You
millimeters.
can barely see it, right? All right, at any rate, let's take a look at how it works, and we're going to be talking about retropulsion here. Phase 1, you got 3 contractile waves a minute. The red are obviously they're larger portions of food, because you know when you eat a chicken, well, you chew it up with your teeth. That's good, but it's pretty solid when it goes down there. And these are smaller particles. How do they get smaller? The secretions like pepsin, okay. We'll deal with some proteins, okay. And then acid will help. At any rate, what's happening is the contraction comes down here, moves toward the pylorus, right? And the pylorus will allow only small particles to get through, and as that remember it's getting stronger as it comes down, and as that contraction comes down, it's so strong it even includes the pylorus, okay? Does this make sense so far? These are pictorial, but they tell you the story, right? You know we're not dealing with red circles and blue dots, we're dealing with food, right? And it's just bigger versus smaller. So what this does is pushes the material back up, leaves it back in the stomach, let the secretions take place until it's reduced again, and 3 times a minute this is going to happen. And the only particles that will get through are the small ones, okay? And as it approaches, okay, let's get to emptying. This is mixing. Is this good? Now, if the pylorus is closing down all the time, how do you get the stomach to empty anything, right? Water, things you ingest, you don't have to worry about that. It just flows right through the pylorus, right? All right, there's something called antroduodenal coordination. It involves the antrum region, pylorus, and duodenum. Now, I'll review this for you. You'll get it again when we get to next week. Maybe even later than that, the small intestine and motor activity. But in the duodenum, it's 12 times a minute maximum contraction. So it's contracting at a high rate. Now, if you're going from, you want to empty, you don't want those contractions, because that's going to prevent emptying, right? Well, let's take a look at this. During antrum contracts, we know that, it's going to contract. But now, instead of the pylorus coming down and closing, every once in a while the pylorus is going to open up, okay? And a spurt comes through. Your stomach doesn't empty like, well, that's obvious from that retropulsion. You move things back with the strong contraction, but every once in a while when you're coming down with that strong contraction, the pylorus will open a little bit, fluid goes through. But it goes through in spurts, well, 3 times a minute maximum, right? And it enters the duodenum. And at the same time, you don't want the duodenal contractions. At 12 times a minute, you're not going to get any food to leave. Or chyme is called at this point. You know what chyme is? Yeah, you've had. Is that okay now? That's how you get gastric emptying. So what the stomach is doing, proximal parts pushing down, right into the blender, and then you've got these contractile waves coming down, smashing against the pylorus. Retropulsion, because the whole thing contracts and pushes the larger particles back. The only thing that got through would be like the liquid or the less viscous material, okay? And then every once in a while when this contractile wave comes through, the pylorus opens slightly, allowing emptying, okay? Yeah.
How often does gastric emptying occur in like per minute?
I don't know. You get 3 times a minute you can have maximum, but usually it doesn't open every time. Usually you have partial opening, partial complete closure, okay? But the exact number, I don't know. Let's say once out of every 3 contractions it'll open.
So that's pretty.
And that's a guess. Just guess. But are you getting the idea? Every once in a while it's going to open up a little bit. Okay, so that's called antroduodenal coordination. You have to coordinate the whole thing. All right, let's say you want to change gastric emptying. You can pretty much guess how you're going to do it. Can you guys see the green line? Yeah? Yeah, they're not that dark. I wish they were, but... all right. Enhance emptying. Take a guess what you're going to have to do. And they're going to be all listed right here for you. If you want to enhance emptying, the black line is what's enhancing. Here it's going to be relaxation or slowing. So you're going to push down on the food. That's going to help move things. If you're on a blender, you push down. It's going to help, right? The other thing is increase peristaltic contractions, right? Decrease the tone of the pylorus, let it open up, and no contractions in the duodenum. And here they'll show you contractions in the duodenum. Okay. What if you want to slow gastric emptying? There's only so many things you can do with this muscle, right? And they're just the opposite of inhibiting or enhancing. If you want to slow things down, increase the duodenal contractions, okay? Decrease the tone, let it accommodate more. It's like you're letting go of this instead of pushing down. Is this making sense? Yeah. And then you decrease the number of contractions. Even though you can contract at 3 times a minute, you move it down to 2 or 1. Slow it down, right? And all these things will slow emptying, or if you want to increase it, it's pretty obvious, right? We've covered all these muscles and how they work. It's kind of logical, yes, no? Does anybody have a problem with that? So, yeah.
What about the reflexes? Are they considered conditions in hospital?
What about the what?
Reflexes.
Reflex?
Yeah.
We'll get to that. Okay, if you're patient. I usually have it organized. This is what you're talking about, I hope. This is called intestinal regulation of gastric emptying. There's a reflex, and these are the arrows. I didn't draw this, I copied it from somewhere. But I drew the arrows, okay, and the minus sign. That means there's going to be a negative influence. I think I mentioned that before with secretion. If you're going to be dealing with something downstream, trying to affect something upstream, it's rarely going to say more. It's usually going to be slow down, okay? So when things hit the duodenum, there are certain things, chemicals or distension or whatever, that are going to go back and say no more. They're going to slow things down. And you can have an effect on the proximal part. What are you going to do? You're going to relax it, right? All right? Now you're going to have effect on the distal part. You're going to reduce the antral contraction, okay? You may even increase the duodenal contractions, okay? Because based on the last slide we talked about. And they think this is enteric nervous system mediated. And what I've listed here is the afferent arm, efferent arm. You know afferent, efferent? The signal's coming from the duodenum. What's going to do this? Irritant. Acid. You're getting too much acid. And I think we talked about that the last time. You're going to inhibit secretion, acid secretion, if you have too much acid. And on top of that, you're going to tell the stomach no more. Don't dump anymore, right? Right? And the other one is, believe it or not, long-chain fatty acid. Lipids. Long-chain lipids. You're going to slow down gastric emptying if you have a high-fat meal. And actually, to put it bluntly, all of these are irritants, acid and long-chain fatty acids. Then, to some extent, distension. That's true. It will do it. You put a balloon in here, distend it, it's going to inhibit gastric emptying. But how often is that going to happen? What you're squirting into the duodenum is almost a liquid, and it's going to flow. It's not going to distend the stomach too much. I mean, the duodenum too much. Whether this may occur in some pathological situation, intestinal obstruction or something. You may accumulate food and cause distension. But that's why I have it not in bold. And the same thing with hypertonicity. Something that's hypertonic. They used to have something called the dumping syndrome. And people who are sensitive for hypertonicity, they eat a meal, and because the stomach's not, you don't get a lot of secretion, absorption in the, except for acid, but you don't get absorption. Water doesn't move freely in the stomach, right? So you're chopping up things up, putting in chyme. Hey, you drink hypertonic solutions sometimes, or acidic solutions, but the point is, the stomach doesn't process that part. And sometimes people would eat, after eating, they'd flush everything else. We'll cover this when we get to the intestine as well. But they don't have enough of a reflex to stop this gastric emptying that they lose a lot of water into their GI tract. And we'll cover that later in the intestine in more detail. But hypertonicity can do it. It's just that when you get to the duodenum, it corrects hypertonicity almost immediately. Okay, we'll cover that when we get to the intestine. And that's why I have it as now. But the reason these are listed is because it's analogous to someone putting amino acids in the stomach. Yeah, you can get them to do something, but is that going to happen? What people do to study these reflexes is they'll have a stomach, and then they'll put in long-chain fat, hypertonic material, acid in here, and see what happens, okay? It's not like they follow the whole process and then they measure pH or measure hypertonicity, okay? But this reflex exists, and it slows gastric emptying. By fundic tone, we know it's going to be nitric oxide and VIP. These things have not been looked at very carefully. More than likely, it's acetylcholine or substance P, but we don't know that. Now, Guyton mentions it, and some books mention it as well, although it's not as popular as it used to be, and I'll show you why in a minute. something called enterogastrones. You know how the medical usage of entero will mean intestine, gastro, it's like a reflex. So it's, an ons usually refers to hormones. So a long time ago, they used to think, well, some textbooks still have that. Long time ago, they used to think that hormones are released from the intestine and act on the stomach in a similar way to a neural reflex and slow down gastric emptying, you know, based on what's entering the intestine here. Well, we know better now, and I'm not going to complicate things, but the one that has received the most, the reason they say this is because this inhibition happens so fast that a hormone circulating through the blood and coming back cannot account for it. So it has to be something else. But everybody knows that cholecystokinin goes up after fats. Long-chain fatty acids are a major stimulus for cholecystokinin. You'll get that in the pancreas. Remember we talked about secretin? It's released by acid. The same thing will hold for secretin. I'm going to show you an example for CCK. But for secretin, acid comes in the duodenum, it's released. Now when long-chain fatty acids come into the duodenum, cholecystokinin is released. It goes to the pancreas and stimulates enzymes to come out, okay? And contracts the gallbladder. You'll get to that when you get to the liver, but the gallbladder has things like bile salts, which help to digest the fat. If you don't have the bile salts, you can have a real problem digesting the fat. The major thing the cholecystokinin does is cause contraction of the gallbladder. Okay. Anyway, CCK was most likely candidate as being an enterogastrone. But see what I have here? Most likely via NAS, all right? I'm going to show you the slides, and it says right here, you don't have to memorize it. Don't worry about it. Take a look at it if you want. But here you got fat or distension, let's say fat, lipid. Yep, CCK is released. But if you remember these diagrams when they showed you the enteric nervous system and then the parasympathetics and sympathetics coming down, you had these afferent nerves coming up from the mucosa, right? Well, these nerve terminals are not sticking out into the lumen. They're in the interstitium. Something has to activate those. It has to go through the epithelium. You either break the epithelium and you can activate these neurons, or something's released from epithelial cells that activates the neuron. These neurons here have receptors. It's called this, obviously, CCK1 or CCKA. But don't worry about that. But remember, CCKB is in the stomach for gastric. This is another receptor, but it works for cholecystokinin. And what happens is you get coming down, NO-VIP being released. You can look at this at your leisure, but this is the current thought, and also it's the same thing with secretin, which would be released with acid, okay? And irritants also is a neural reflex. So gastrones are losing popularity. People are starting not to use that word anymore, but you can't deny that CCK is involved. You're not going to be able to activate these nerves unless something from the epithelium, okay, the CCK secreting cells, unless they're able to secrete the CCK, you're not going to activate that receptor on the nerve, right? This makes sense? Okay, you don't have to know it. All right, we covered what's going on in after a meal, pretty much. And this is called, well, fasting or interdigestive. I don't know if you want to call the period between breakfast and lunch as fasting. You know, maybe. But you think of the word breakfast. You're breaking a fast. Well, you weren't really fasting, you were sleeping. But you weren't eating is the point. So in between meals, you have another form of activity going on. And this one produces very strong contraction. And again, you see antrum, duodenum, proximal jejunum, and these are contractions, right? And then nothing, and then 90 minutes later, another contraction, right in the same place. What's important is it's migrating. It's called the migrator motor complex. migrating myoelectric complex, they have different names, but the word migrating tells you it's moving down. I used to have a cute picture, but I can't find it anymore, of a broom going down the GI tract, and that's what it's doing. It's moving everything that's not been processed, or it's cleaning out your GI tract in between meals, okay? Bacteria, dead cells that were shed, everything. And even though you're not eating, it comes down. It comes down every 90 minutes or so. Do I have that written? Every 90 minutes. Motilin seems to be a hormone that's involved. They haven't worked out how it does that yet. They think it has a neural component, as we talked about before, but we don't know that. So Motilin is involved. And the important thing is the pylorus is wide open. But and you can see here that it doesn't start in the fundic region, it starts in the anthem. It doesn't start in the fundic region. Why? You don't have slow wave. Right? You can't have contractions in the fundus. It starts in the, there's no food in the stomach. And all of a sudden this contraction goes down, pylorus opens up wide, and it just moves down the ileum. And that's where it ends. It's the distal ileum, doesn't go through the colon. We'll repeat this again when we get to the intestine, okay, so don't worry about it. But one thing that is important is that when this one's ending over here, you see another one starting. So this keeps going, goes down to the end. That's why I like the broom. The broom comes back to the top and sweeps again. It's cleaning out your GI tract. Motor activity. Because you know with peristalsis, you're going to be moving material downstream, right? Is that right? That's the point of peristalsis, right? Contraction. And it's migrating. All right, here's a little anecdote that we can try out. Remember I said pylorus is 1-2 millimeters you can get through the pylorus usually. That's what it's called, open. Usually it's closed, 1 to 2 millimeters. And yet you know you eat corn or something like that. People eat corn every once in a while. Yet you know corn gets through. I mean, don't ask me how you, right? How does the corn get through if you got this one, it's too big for corn to get through? Well, the pylorus stays wide open, and it's in between meals. When this migrating motility complex, it empties out the stomach. If you don't empty that stomach or clean it out, you're going to have a problem. Even undigested, like cellulose, very difficult to digest. And yet you don't want it building up in your stomach. So this harder material, not harder, more viscous material, or celery or something weird like that, it may require, between meals, the migrating motility complex to empty from the stomach and move it downstream. Yeah.
So the entire contraction starts from the pacemaker and goes all the way down?
Goes all, see, it goes from the antrum all the way down to the distal ileum. There's this one wave. This is recordings of electrical activity. I have an appendix that talks about, I'll show you that in a minute. And I should have probably put it in, but you don't have to know that at this stage, unless you're going to be a gastroenterologist. At any rate, it moves down, see, it's moving down, 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 down. And when this one reaches the terminal ileum, here, you know, I guess the way to look at it, there's nothing going on in the terminal ileum here, but there's a contraction starting in the antrum. It takes a while for that contraction to show up, and it's moving down. Every 90 minutes. They have different phases, but don't worry about it. The major phase is phase 3. That's the one that's the strongest contractile phase. But they arbitrarily divide into phase 1. Phase 1 is nothing. Okay. Why call it a phase? Phase 2, it's starting. Okay. Phase 3 is the strongest contraction. That's it. All right. Corn. That was one example. Now, as a physician, you're probably going to run into some hysterical mother or something going, my child just ate a quarter. Or what's your coin? You guys have coin, right? Not little toy, something, paper clip. My child swallowed this big coin, or a key. What are you going to do? Well, you know, a dedicated physician, well, we'll cut them open and take it out. But you don't have to do that. You know what? He'll say, take it easy. The MMC will move it out. It'll go out into the bowel. Okay? That's not a problem. By the way, not to, well, never mind, I'm not gonna get into that. That's illegal anyway, but some people ship drugs, humans, they call them human mules, they swallow it. That's how they recover those drugs. They have to wait till a person goes to the bathroom. Well, think about it. But it's the same thing. You're not gonna just, in other words, you're not gonna be concerned. The mother is, my little boy or little girl just swallowed a big key, what's wrong? Yeah. Between meals, it'll come out. Okay, that's one of a major thing to the MMC, cleans things out, okay? All right, this is emptying of food. You got a lot of food here, 100%, filled up stomach, and less food, right? And it comes down like this pretty fast. Liquids, you can take a guess. It's gonna come out pretty fast. You can drink water or some kind of a, I don't know, Coke, whatever you drink, all right? Liquids will come out faster. Over here, we're adding nutrients to the liquids. It's gonna take a little longer, okay? That's because some nutrients will hit the duodenum. You might get some inhibitor, but it's a liquid, right? And, or homogenized solids. I like that word. In other words, you can take a liquid or you can take a meal, put it in a real blender and blend it up and just swallow it. It'll empty pretty fast because you don't need to break it up, right? You don't need to make it smaller to fit through the pylorus during the contractile wave in the antrum. Now, when you get to solids, low-fat solids, here, high-fat solids. And that's important. That's why some people who have, it's called gastroparesis. That means they have real slow gastric emptying. It's a problem. Physicians will put them on a diet, low fat, because fat will inhibit. Remember this line? Long chain fatty acids. Or get yourself short chain fatty acids. It won't stimulate. But at any rate, low fat, it'll empty. It'll take longer to empty. High fat, even longer to empty. This is called lag time. And it'll happen for solids. It doesn't matter whether they're high or low fat. It takes longer. But what's the lag time due to? It's a solid. So, remember, it's hard to understand, but we covered it sort of. You have this antral contraction going down toward the pylorus. Everything smashes down, pushes everything back. The lag time is primarily due to the fact that you have to yourself homogenize that food to get it into this kind of a emptying phase. You gotta make it more liquid, right? That's why corn's not gonna really empty, or a key, or a coin. But now, and the high fat, you're also bringing in your intestinal reflexes, right? They're gonna slow emptying, right? Everything. So now this lag time, it depends, but here with a solid, you get some lag time, and then it'll start emptying regularly. Squirt, squirt, squirt. Well, the pylorus will open up more often to allow it to squirt. Is that okay? This is the thing to, if you want to, before you look at those pressure curves I showed you, this is manometry. It's a review. It's supposed to be a review because I thought you guys covered it during the esophagus. And here's your swallowing, and it shows you the tube, and these are the holes at different places. And this is the LEF. And here they're showing you the lower esophageal sphincter relaxing. What's happening here is you swallow it, you get a contraction. Upper esophageal sphincter relaxes and then snaps shut again. And then this wave migrates down. But even before this wave down the esophagus, the peristaltic wave coming down the esophagus, even before it reaches the lower esophageal sphincter, it's already contracting, relaxing, and then overshoots to make sure that there's no reflux. That's the